All right, on this video, we're going to look at how to solve a linear and nonlinear function or system by graphing. So the solution to a system can also be found by graphing the two functions and visually identifying where they intersect. So the previous video, we did this algebraically, finding the two spots where they intersect, the two coordinates. There can also be one or no coordinates, but so far it's generally been two. That's almost all the ones I've seen. So you're going to have a linear function and you're going to have a quadratic function. And we're going to graph both of these. So for a linear function, they're giving it to us in slope-intercept form. So I can just look at what's next to the x. That's my slope. So it's going to be 2 over 1. Remember, it's always a fraction. So if I don't see a fraction, my run is 1. And my y-intercept is what's being added or subtracted. Well, since there's nothing added or subtracted, I know my y-intercept is 0. So I can already graph this point. So I can start with my y-intercept. I can go up 2 over 1. And then I can graph a line. So I have my linear function already. Now I need to do my quadratic. I do want to identify my axis of symmetry so that I know the x-coordinate of my vertex, because that'll definitely be very helpful to pick my points. Because remember, when you're graphing a quadratic, you need 5 points. You need the vertex and 2 points to the left and 2 points to the right. Okay. So I know it's been a little while since we've graphed a whole lot of quadratics, but we did this a lot in the first semester. So our axis of symmetry, the equation is x equals negative b over 2a. So if I look at this quadratic, I have a, because that's where the x squared is. It's the negative 2 here. That's my a. And I don't have a b term because that would be what's next to the x, and that's missing. The middle term is missing. I have my 4, that's c. So b is actually 0. If it's missing, it's 0, just like the y-intercept was here. So that means I'm going to have negative 0 divided by 2 times negative 2, which is just 0. I don't even need to figure out what the bottom is. If I divide anything from 0 there, I'm going to get 0. So I know my x-coordinate for my vertex is 0, so I can plan 2 points to the left and 2 points to the right of that so that I can correctly graph this quadratic. And Alex is somewhat picky about this. If you're not very close, like I would only go out negative 1, negative 2, 1, 2. I wouldn't go out farther than that, only because Alex starts to do this funny kind of W graph. I've seen it do it before, if you go out too far. So just try to stay as close as you can into the vertex, only stepping away one at a time there. All right, so we're going to plug in negative 2 to our equation. So negative 2 squared, well, that's 4. And 4 times negative 2 is negative 8. And negative 8 plus 4, that gets us negative 4. And then we have negative 1 squared, which is 1, times negative 2, which is negative 2, plus 4 is 4. Plus 4 is 2. Said that funny. Negative 2 plus 4 is 2. And now we're going to plug in 0, so that completely zeroes out this whole section. So I have 0 plus 4, so just 4. And I'm going to plug in my 1. Now, at this point, we should notice these should mirror. I should have 2. And my last answer should be negative 4. I should definitely see this mirroring happening because I'm framing this at the bottom. I'm framing it around the vertex. So I should see the mirroring of the answers here of the y coordinates. So 1 squared is 1 times negative 2 is negative 2 plus 4. So you notice it's the exact same as that second one we did. So we get 2. And then 2 squared is 2 times negative 2 is negative 8 plus 4. Again, you notice it's like the very first one we did, so it's negative 4. So there are my 5 points, and there's my quadratic. And now you're just looking for where are the 2 points they cross, which by chance they cross right over one of the points that we graphed for our slope, which is nice. The bad thing about doing this on paper is you need to be very, very exact when you're drawing this. And it's kind of hard to be exact drawing a quadratic because you really have to go pretty far. But by chance, one of our points lands right on top of the line, so that's also a nice feature. But if you're doing this on Alex, you don't have to worry so much about being exact because it's gonna be exact for you. And then you can identify the pieces. So we can see here's a solution at the bottom, here's a solution at the top. Those are the 2 points that the 2 graphs cross. So my 2 solutions are negative 2, negative 4, and 1, 2. All right, let's try one more of these. So my quadratic is on top now, and my linear is on the bottom. So I'm going to do the same thing for my linear equation. My slope is in front of the x there, so it's negative 2 over 1. And I do have a y-intercept this time of 2. So I'm going to graph that. I'm going to go up to 2, and then I'm going to go down 2 over 1 for my slope and graph my line. So my linear is already done. Now I'm going to do that same thing for the axis of symmetry so that I know to graph it. Well, if you notice, this is doing the exact same thing. I have an x squared, but I don't have an x term. So I have an a and a c, but my b is 0. So it's going to be that same idea. It doesn't really matter what the bottom is. 0 is on the top. So again, my vertex is going to be at 0 for x. So I can frame it right around that 0. All right, so if we plug our numbers in, I have -2 squared, and I get 4. 4 minus 1 is 3. And then -1 squared is 1. 1 minus 1 is 0. I'm going to plug 0 in, which just zeroes this out. So I have 0 minus 1, which is -1. 1 squared minus 1. Well, that's 1 minus 1, which is 0 again. And we see that mirroring happening. So our last one should be 3. So 2 squared is 4, and 4 minus 1 is 3. All right, so now let's place our 5 points. And again, one of these nicely crossed. Now I had to do a little bit of tweaking on this one because I didn't quite have the right shape for my parabola when I first did this. So again, that's that issue of doing it on paper. I had to kind of play with it, and I even had to go on a graphing calculator to make sure I had the correct point because it was landing a little farther over, kind of like in the middle here. So I had to kind of tweak it a little bit. Now in Alex, you won't have to worry about that. It's going to do this perfectly for you. But again, on paper, this can be a little bit more difficult to do. I would definitely suggest doing this on a graphing calculator as opposed to doing it on paper. But you can see here are our two solutions. So I have -3, 8 and 1, 0. So this is how you find the solutions to a system of equations, one linear, one nonlinear, with graphing. I hope that helped, and I'll see you in the next video.